It is possible to add another underground feeder from the existing switchboard to a third distribution panel with a main breaker in the addition, provided that specific requirements are met. These requirements primarily stem from the National Electrical Code, or NEC. Section 225.30 it dictates that service conductors must have sufficient ampacity to supply the imposed load. Ampacity refers to the current carrying capacity of a conductor, and it must be adequate for the demands of the new panel. Section 240.21F covers grounding. It specifies that the grounding electrode system must be connected to the grounded service conductor of the service entrance conductors and to the equipment grounding conductor of the feeder. This ensures a proper path for fault currents, enhancing safety. Sections 300.5d, 300.35, and 300.36 govern the installation of underground feeders. Section 300.5d refers to a general article for the installation of underground feeders, while sections 300.35 and 300.36 specify that the underground feeder must be either directly buried in the earth or installed in conduit or raceway. The choice depends on local conditions, soil type, and protection requirements. Beyond the NEC, several additional considerations are crucial. The conductor size for the underground feeder must be determined based on the load demand of the new PAL and the distance to the switchboard. Longer distances introduce voltage drop, requiring larger conductors to maintain adequate voltage at the panel. Coordination is essential. The feeder from the switchboard to the new panel must be coordinated with the existing feeders to ensure proper overcurrent protection. This involves selecting appropriate fuses or circuit breakers to protect the conductors and equipment from overloads and short circuits. The third panel must be properly grounded using the same grounding electrode system as the existing panels. This ensures a common ground potential, minimizing the risk of electrical shock and equipment damage. All electrical work must be permitted and inspected by the local authority having jurisdiction. Permits ensure that the work meets code requirements, and inspections verify that the installation is safe and compliant. Here is a step-by-step procedure to follow. 1. Design and size the underground feeder based on the load and distance. This involves calculating the load demand of the new panel, considering factors such as lighting, receptacles, and equipment. 2. Excavate the trench for the feeder installation. Trench depth must comply with local codes and the NEC, typically requiring a minimum depth of 24 inches for direct burial. 3. Install the feeder in accordance with NEC Article 300. This includes selecting the appropriate wiring method, such as direct burial cable or conduit, and ensuring proper support and protection. 4. Connect the feeder to the new panel and the existing switchboard. This requires careful termination of the conductors, ensuring secure connections and proper insulation. 5. Install a main breaker in the new panel. The main breaker provides overcurrent protection for the entire panel and serves as a disconnect for servicing. 6. Ground the new panel and connect it to the existing grounding electrode system. This involves connecting the panel's grounding bus to the grounding electrode system, typically using a grounding electrode conductor. 7. Notify the local authority for inspection and permitting. This ensures that the installation is inspected and approved, verifying compliance with all applicable codes and regulations. For conductor sizing, start by calculating the total load that the new distribution panel will serve. This includes lighting, receptacles, HVAC equipment, and any other electrical loads. Use the NEC to determine the demand factors that can be applied to these loads, which account for the fact that not all loads will operate simultaneously at their maximum rating. Once you have determined the total demand load, calculate the minimum ampacity of the feeder conductors. The NEC provides tables that specify the ampacity of conductors based on their size, insulation type, and temperature rating. Remember to select conductors with an ampacity that is at least equal to the total demand load. Next, consider voltage drop. Voltage drop occurs when the voltage at the end of a conductor is lower than the voltage at the source due to the conductor's resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to 3% for feeders. Use a voltage drop calculator or formula to determine the voltage drop for the proposed conductor size and length. If the voltage drop exceeds 3%, you will need to increase the conductor size. For overcurrent protection, the feeder must be protected by an overcurrent device such as a circuit breaker or fuse. The size of the overcurrent device must be coordinated with the ampacity of the feeder conductors. The NEC specifies the maximum overcurrent protection for various conductor sizes. The overcurrent device should protect the conductors from overload and short-circuit conditions. Coordination involves ensuring that the overcurrent devices in the system operate in a coordinated manner. This means that the overcurrent device closest to the fault should trip first, minimizing the extent of the outage. For grounding, the new distribution panel must be properly grounded to ensure safety and prevent electrical shock hazards. The grounding system must comply with the requirements of NEC Article 250. The grounding electrode system should consist of a grounding electrode, such as a ground rod or a metal water pipe, and a grounding electrode conductor that connects the grounding electrode to the panel's grounding bus. The size of the grounding electrode conductor must be based on the size of the feeder conductors. The equipment grounding conductors must be properly sized and connected to the panel's grounding bus and to the metal enclosures of electrical equipment. For underground installation, NEC Article 300 provides detailed requirements for underground installations. The feeder conductors must be installed in a raceway such as rigid metal conduit, intermediate metal conduit, or rigid polyvinyl chloride conduit, or they can be directly buried if they are specifically listed for direct burial. The minimum burial depth depends on the voltage of the feeder and the type of raceway or cable used. The trench must be properly prepared and the conductors must be protected from damage. For permits and inspections, before starting any electrical work, obtain the necessary permits from the local authority having jurisdiction. The permit application will typically require detailed information about the project, including drawings, specifications, and load calculations. Once the work is complete, schedule an inspection with a local authority. The inspector will verify that the installation complies with the NEC and other applicable codes. Do not energize the new feeder until the inspection has been approved.